But anyway, we do have a lot of questions from the audience. If you don't mind fielding a few.
Sure, be glad to.
Okay, some people have asked, we've mentioned
Build a table in the hall and
that
send all the cables got down through.
use here. We're not allowed to use them. Why do cell phones, why are they a problem for the telescope operation?
Just going in a circle.
We have a lot of telescopes up here on RKS, and they look in different wavelengths of light. For example, here we are at the IRTF. It looks at infrared radiation. We also have a submillimeter telescope that looks like a little bit longer wavelengths and microwave wavelengths. And so it looks like cellular phones transmit wavelengths that will cause noise or disruption in some of these wavelengths.
Now, is it true that it's noise disruption? That's bad, not only because it's noise control, but if they don't notice that can be misinterpreted in the data and actually cause small research. Is that possible?
I don't really know. I suppose that's possible.
I'm sorry. I've always wanted to be on the inside.
Well, maybe you can have something there.
Okay, well.
Spurious signals can look like data sometimes.
Well, another question that we had, this is one that we've had a lot, and so it bears some discussion. We've talked a lot about the different spectrum telescopes that we're using, calcium K, hydrogen alpha, white light, things like that. And a lot of our viewers just don't understand what we're meaning.
So my easy
I know I don't understand what we're meaning. I'm just here, having a good time. But maybe you can
however, still learning based on the data that's been
sure, well, I'm just here having a good time too. Answer that question. We're actually looking at the sun in different wavelengths of light. Now, what we call
what does that mean? Okay.
Okay. Well,
I'm sorry.
Light, as we know, it's known for about maybe not too much more than 100 years or so. Light behaves as a wave.
That's for another show.
Light was first understood as something that was probably a lot like sound waves. And of course, it's a little different than sound waves because it doesn't need a medium to propagate through. But you can think of if you drop a pebble into water, you can see the waves rippling. It's kind of like that, a rippling.
Okay, so if we're looking at different waves of light, and the calcium K being one wavelength, and H alpha and white light, what is the benefit of looking at those different wavelengths?
Sure. Well, first of all, hydrogen alpha is a red wavelength. It occurs in, I forget what it is, something like 650 nanometers or something. Calcium K is in the blue, it's 390 nanometers. And as you look at different wavelengths, you're also sensing at different levels of the sun. Different temperatures produce different wavelengths or frequencies of light. And so we can see a little bit different parts of the sun. The universe in general looks different depending on the color of the light that you look at it in. And so we can get a little bit different definition by looking at these different wavelength or frequency ranges.
Okay, so that's what we're getting. Not only is it different pretty pictures for us, actually when scientists look at it, they learn different things looking at the different spectrums.
That's absolutely right. And so that's one reason it's very important for us to get up above the atmosphere. We're up above a lot of the atmosphere here, and we're noticing it.
Is wind part of the atmosphere? Because I'm feeling like if it is, we got to be dumped down on us. I don't know if the audience can sense it, but it's winter conditions up here.
It's freezing. That's what it is. It's freezing.
Yeah, you need some gloves. Question? Oh, I got one here. I got more for you. But for anyone to chime in if you have any thoughts on this. We have one question from a character named Roman out in Ohio. And what he wanted to know was, does the Earth cool maybe as a result of the sun, Venus transiting the sun? Now, I don't know the answer to that question, but I can say right now, it's cool here. We're in the blinding light of the sun, but the temperatures are very chilly. I don't know if that's a result of the transit.
Probably not a result of the transit. It's the result of the fact that the primary cooling effect in the lower
Because
atmosphere
that's
where
what
we
he
are
has done.
is
That's
by
why
heating
he's
the surface of
training
the earth and the
down on
surface of the earth heating the
streets
atmosphere.
where
So as we
police
go up higher and
train
higher, we
rival
get colder
gangs,
and colder
literally.
then other physics takes place. But to answer his question, Venus appears to us in this transit to be about 1/30th the diameter of the sun. For the amateur astronomers and scientists watching, it's about 1 arc minute in diameter. And so, in terms of the area of the sun, it's approximately 1/900th the area of the sun, or roughly 0.1%.
Okay, now that's interesting because I had a conversation with supersolar physicist Holly Gilbert about this exact same issue, and she said it's interesting during an eclipse you might in regional areas sense a slight change in temperature because you're in shadow. But she went on to say that we're, because of distance and everything else, we're probably not even feeling or getting a shadow of Venus on Earth's surface.
That's right. Yeah, Venus is so much further away, so much smaller in terms of apparent angular size, and of course it's only in a total solar eclipse you're blocking out all of the sun, and Venus is only blocking out about 0.1%. So it's unlikely that we're going to be able to measure any effect in temperature from the Venus transit.
Well, I mean, it's good to rule that out. You know, now it's something else. Franklin, you got another question?
Since Venus is so far away, we had one of our viewers ask a question: how long does it take for the images that we're actually seeing of the Venus in the sun to get to Earth?
Oh, that's a great.
This takes time for light tracks.
That's right. We live in an age where we know that it takes light time to travel.
JCDC part of the
8 meters per second. I guess it was in 1600s, I think, where they finally figured that out. They used to think light was instantaneous. But the distance to the sun from the Earth is about 150 million kilometers. Venus is about 0.7 of that distance. So let's call it.
For the record, the altitude is why we're allowing you to wing it.
Just wing it here. It takes light about a little over 8 minutes to reach the Earth, and so probably something like a third of that. So a little less than 3 minutes from Venus.
Gotcha, right.
From
Okay.
Venus.
Gotcha. So still 8 minutes from the sun.
The 3rd minutes from the sun.
Very good.
prophecy that.
I got another question. One viewers wants to know what is the small dots? We can't see the monitor right now that is on the surface of the sun that appears to be the same size as Venus.
Devils today, Satan.
Well, I would imagine it's Venus.
No, above Venus. It's around. There's spots on the sun, surface of the sun.
Oh, okay.
So Satan says to the devil,
As Holly, Gilbert, and others have talked about, we are in a period of very high solar activity here, which means that we should be seeing a lot of sunspots, and we are in fact today. Sunspots are local disturbances on the sun, which are relatively cool compared to the rest of the surface of the sun, high magnetic fields and all that stuff. And so because
where
they're
the devil's in
relatively
charge of the world, invented mind of man.
only about
The devil's invented
3 to 4
Lucifer is mine.
they appear dark.
So as of now, I say Lucifer.
And some of them can get quite
Man
dark.
becomes recognised.
Yeah, and
as
it's
the
interesting
man that
because there is lots of solar activity. There could be other issues as well. I think somebody was suggesting clean your monitor. But seriously, there are solar flares and solar activity happening all the time.
So we get that loaded up.
But we're in solar maximum, which we talked about earlier. So it's likely that there's lots of activity.
Zip here!
That's right. And we're still hoping for a good solar flare or
Yeah.
We plug that into your tube.
Holly's not that we promote emotional breakdowns, but she's promised a good cry if there's a solar flare while Venus is crossing. So, we want to see if she's true to her word.
And one final question, Lou. We are up here on this on
Can I
Mauna
get to anything
Kea,
else?
and when we
Pardon?
talk about
Can I get to anything else,
being
Mikey?
exposed to the sun and
Nothing. Water.
the
No,
elements,
nothing. I'm
how
right.
much more are we?
I'm
exposed
fine, thank you
to
very
being up on Mauna
much.
Kea at 14,000 feet?
Well, we're up about a good part of the Earth's atmosphere here, and thankfully we have not only a magnetosphere to protect us, but an atmosphere. And our atmosphere filters out a lot of radiation from the sun that would otherwise reach the surface of the Earth and would be really bad for living things. Gamma rays, X-rays, and most ultraviolet light, as well as a lot of infrared light because of water absorption. Up here we're getting a lot of ultraviolet radiation. Probably about if there were no things reflecting light, we get about 60% more UVB than at sea level. But probably we're getting with all this reflecting. So I'm guessing about 100% more UV.
I would challenge you on that to raise that to 150%. But however, and I just want to let my wife know, yes, I did apply sunscreen liberally on my face today, so I'm protected. But I probably need to reapply because we've got blinding levels of UV bouncing off this building right into the cornea.
Thinking about
And
bloodline.
the skin too, which is what we're really protecting. I'm rambling, but that's because
That's where Richard comes in.
Yeah, he must be
take a break
Illuminati
from my health
bloodline.
Yes.
to others. But
So
what we
he's-
want to do
so Adam is-
look at
That's why
the
they traced
images
him
that
out.
we're
Everybody's
getting.
too stupid to know.
Hopefully they can bring them up while I go hit the oxygen tank.
It's now the man that's had more bypasses in
You're
history.
watching live
Yeah.
Venus Transit 2012 on
More
NASDAQ.
stents,
And
plus a
inside and outside
bypass.
left, it all things left.
Thanks, Lou.
And the bad news that Aaron was saying that they got is that they told him that he didn't have long to live. That was back in, March. He's still, so he's of the Illuminati bloodline. So we bring forth Adam, who's from Jesus and Martha, and the Illuminati. So we've got both sides there, and Adam's taken after the mother, who is after God, of course. So,
In the end, God wins. Would that be a fair summation?
Absolutely. It's all genetic.
yeah.
I'll look up some numbers, darling.
Okay. Lessons on.
1217. $8.23, $8.21, is that right? Yeah, give me an exact contact.
But 1217,
8:11.
811. 811 in Greek. Dissolutely, riotous in Greek. Cluster of grapes, a bunch of grapes or other fruit.
Okay, 8:29.
In Hebrew is a measured portion, good piece.
Okay,
of flesh.
8:30.
Why don't we do it in Greek? 8:30, 8:29 in Greek is self-willed, arrogant, self-pleasing, and then 8:30 is of own accord, willing of self, voluntary, self-chosen.
Okay, now I'll run this right back. And what I'm going to do there is a sun flare coming around. And the moment it lines up with a sun flare,
Yeah,
that's what we're looking for.
all right.